Matt Robinson. I'm your gracious host for today's community meeting. As always, like a flurry of pressing buttons and making sure Zoom is not being under a denial of service attack, but we're all good, it looks like. So with that said, let's see if I can get the slides to advance. Yay, technology. So anyways, community meeting, right? So we try to do these quarterly. It's a chance to kind of check in and understand and kind of update the broader community about things that are taking place under the ROS-Industrial umbrella. And obviously where we can, like, have various kind of ROS-Industrial collaborators and consortium members talk a little bit about what's going on and what they're doing. So, so today I will talk a little bit about at the ROS-Industrial level, the open source project, and kind of like what we're doing as far as community and outreach. And then I'll kick it over to Michael Ripperger, who's on the line. He's our ROS I America's tech lead. He'll say a few things, and then we'll kick it over into the actual, like, sort of the meatier part of the program. So we have Brad here today and one of his technical colleagues, Oded, to talk a little bit about some things going on in the real sense world. We have one of our team members here that's been supporting a NIST grant for a framework to support developing reinforcement learning policies for assembly tasks based on the NIST board. So we'll kick over for that for a little bit. That's John Bonin, he's online. And then Dave Coleman today will share a little bit kind of like what's the latest around Move It and Move It Studio. If we have time permits, we can always just like kick it over and you guys can grill or pepper me or any of the speakers with all of your questions. And we'll kick it off and we'll close it up for the day. So that's kind of what we're going to do today. So I really want to touch on the at the ROS-Industrial level that we're interested in working to continue to foster collaboration, right? So it's not like, I want to be clear, like, right, it's not like I don't mind chasing cats. You know, I do a lot of the cat chasing and herding, that's fine. But ideally right now that we're able to kind of get back to, this is obviously an online event with all of its usual trappings and challenges. But as we get back to face-to-face events, running into each other at IMTS or the Vision Show or AMR Show or ROSCON, that obviously where it helps, right, get together amongst yourselves. Hopefully, you know, putting a face or a name to real sense is helpful to the community. And then that hopefully facilitates greater collaboration, right? Where that's the whole point of this particular community, for those of us interested in fostering open source resources for industrial applications and manufacturing applications. So we're obviously reaching out and trying to broaden the tent. So most recently been working, attended the research meeting, the annual research meeting for the Founders Society of America. That was really interesting. There's a number of universities doing really industrial relevant work. They're using tools like Move It. They've been poking around with industrial calibration, right? So let's bring those teams together, work a little bit more concerted, right? And hook them up, give them access to training. The American Welding Society has been sort of hands off relative to robotics, and they're now actually officially sponsoring a robotics and sensors conference coming up in October, and I'll be attending. And so that's a really nice turn of events. It's been politically fraught to talk about robots in the welding world overtly, and particularly where AWS sits, because they provide a lot of educational and standard support relative to, you know, usually skilled trades side of welding. So this has been an interesting development. We've long been supporting the Coders Association for those interested in potentially applying, say, like toolpath planning and motion execution for high-mix painting applications. So that's been really fruitful. There's also a forging. I didn't include the Forgers Association, but that's been a really fruitful one as well. A very underserved community where there's a lot of need. And of course, remanufacturing industries. Remanufacturing is kind of like it's a real interesting application for the types of robotic behavior that a lot of us talk about, because every part that comes from the field that needs to be remanufactured is different, right? So as we grow into these tents, there'll be opportunities for those of us who maybe spend more time, like say at ROS, very ROS-oriented events, to interact with people that are in sort of these different kind of, if you will, process-centric domains. And I think that really helps the ROS-Industrial project make sure it stays focused on meeting the needs of people who have like real tangible problems in industry. And sliding advance, maybe. There we go. So with that being said, we are still working on our core tools. relative to kind of what makes ROS-Industrial beneficial to the community. One of these things are continuous improvement of training. You know, we did end up piloting hybrid training. Some of you today, here today, may have attended one of these hybrid sessions, and hopefully it wasn't, or hopefully your experience, if you attended as a remote attendee, was okay. But we had gotten a lot of feedback that the hybrid model was a little bit fraught with challenges. So we've sort of canned hybrid training right now as a thing, and we will continue to work on in-person training with the idea that we will supplement in-person trainings with at least one per year of a totally virtual training event. So instead of trying to service people in person where the instructors are working hand in hand with the students, sometimes the people online get sort of feel left behind or are left behind, right? So as opposed to trying to do hybrid training where some people are online, we're just going to focus on in-person training and then create a specific virtual event for those who want to attend remote, and hopefully that helps. So, but as I said, also moving forward, there we go, separate virtual training. That's what I said. I stole my own thunder. We have one other member benefit that we offer on the consortium side of things is that full members can host a training event. In fact, haven't always been super strict on that. In this case, we're going to be in Boston. So Analog Devices out of their analog garage in downtown Boston will be hosting a training event the 18th through the 20th of October. I believe we still have room for a couple folks. This is in person only. We were prepping to launch a new advanced topic, but per some requests, we're actually going to do a little bit more refinement on the perception pipeline topic because a number of the people in that region really wanted to focus on perception, setting up and tuning perception pipelines at this event. So that'll be the advanced topic. We will set up and target the motion planning pipeline for February 2023, and that'll be here. We're still going to schedule the virtual training. I'm open to ideas on timing. Probably will not happen this calendar year, but I'm open to it being sort of close to the in-person event, maybe while the training's fresh. Typically, every time we do a training event, there's all these opportunities to make it better. So it just depends on how much of the improvements from the February event we want to incorporate and how quickly we turn that around. So stay tuned. This is a slide pretty much almost verbatim from, I did want to hit this at this particular community meeting. There had been some recent commits to improve this application, as well as I believe potentially a new feature. Michael can always follow up if he ends up touching on this for his couple slides. But I wanted to include the repository, right? So we demonstrated this at Automate back in June. Michael recently at the America's Hosted Developers Meeting. As we have a monthly developers meeting, we rotate which region hosts it. So we basically have one quarterly for Americas. I would encourage you, depending on your calendar flexibility, to kind of poke at each of these developer meetings. You can go to rosindustrial.org under developer and find the developer meeting for your region or all the regions and register for those. But Michael did kind of more of a deep dive. I included the link to Michael's overview of the scan and plan workshop, and actually the motion planning pipeline advanced topic will be pulled out of this repository. So this is like the big bang for the buck. And as I've talked about before, we hope to actually create specific workshops. This is actually the picture from the ROSCON workshop 2021. We've now created a collaborative implementation. Oh, wait a second. There it is. A collaborative implementation of this so people can poke around with it and play with it, drive it themselves. And as well as like it's got the full representation of a lot of the things we talk about in, so to speak, a scan and plan context. So that's been pretty fun. I'm already at my time limit. So again, I wanted to highlight we are engaged with the ROS II Technical Steering Committee. We try to represent the voice of our industry stakeholders. So that's what we do there. I wanted to touch on the interfaces working group. I included a link to the discourse post. I was going to put the Google Notes in there, but most recently we've been having some really great guest speakers talking about, hey, here's how we're approaching providing better resource for how we're approaching interfaces to devices, right? So one thing that's still a little bit of gap in ROS II land, if you've done a lot of ROS II work, is there's a lack of supported drivers and interfaces, and we're trying to do what we can to bring a little bit more helpful guidance to the interface development space. And of course, recently over the summer, we did a World ROS I Day and focused on ROS 2 documentation, because that's been another feedback. So we thought, hey, let's throw some of the activity that we do behind specifically this request to support ROS 2 documentation. We do that as well. So that's what we're trying to do to kind of move the ball forward, that both fits within like where we're hearing there are gaps, and trying to do something about it in a way that's collaborative and enables that most engagement, as opposed to, you know, just doing stuff and hoping it sticks. We got a few training. I mentioned the training events in Boston, so that's almost full. I can probably tolerate a couple spots. So if your organization, you have someone that wants to check that out, we will also have this in-person event targeting San Antonio currently. We'll do the new advanced topic. We'll have our next quarterly meeting, this sort of like everyone get together and just share stuff. So if you have a topic you want to hear about at a community meeting, I'm all ears. You can just email me directly. I'm happy to take that under consideration. ROS-Industrial, I believe a couple others here will be exhibiting at ROSCon in Kyoto, Japan. So check that out. Feel free to interact. Michael will be there, Ripperger. He's going to be speaking next, so feel free to chase him down. Give him a konnichiwa for me. ROS IAP workshop, I will be in attendance here on November 9th through 10, supporting our friends at ROS-Industrial Asia Pacific. I linked it as well, so these links will be active in the PDF I archive on the event page. And of course, ROS I EU conference tentatively is the 15th through 16th. I need to confirm those dates with Christoph. I don't see him online today, but yeah, that's a Friday. So that's why I want to confirm that date on the 16th. And then we're targeting co-locating with Automate in Detroit again, but we'll firm up those details later. I won't beat that one up today. That's way out there. We also, per the ROS I annual meeting, we spend a lot of time talking with the members when we get them together in person. This is really great. Everyone has something constructive to say about the state of the ROS-Industrial open source project, right? And that's the chance to get together. What should we be working on? You know, in the end, these training resources and ease of use facilitate adoption. So while we actually hosted a little bit of a chat around roadblocks to adoption, in the end, what we can do to provide a little bit more on the training and resources or ease of use basically break down some of those adoption barriers that we hear from industrial stakeholders, right? So we have some advanced users on the industry side. Spirit Aerosystems is a really great case, and then we have we're you know, their feedback is a little bit more like, yeah, we can use more ROS 2 documentation, or there could be better guidance on how to implement Unity or Isaac Sim. You know, others are like, hey, I just need to know, like, what is ROS and why is ROS 2 so much different than ROS 1? You know, so some of the stuff is very like entry level to advanced users, and it's obviously how do we prioritize that, and that's what we're going to do, a big refresh of the roadmap, and I hope to have some time to get that kind of firmed up and put that out for rock throwing soon. But that's active work. We obviously have been doing a lot of work on collaboration opportunities. These are just the ones that are kind of being championed by members that then like I end up like kind of reminding everyone about, right? So there is another robotic blending that's being championed by the Steel Founders Society of America. This is changing shape currently right now. It's got to be rescoped a little bit. They are targeting deploying at one of their member foundries. So an actual, you know, dropping a system into a foundry environment and having it make real parts. And it'll be great because we'll have university team members, right? So and they're all hand waving like this is grad student code, but that's part of the journey. Like, how do we take good capability nuggets and then turning it into something, transitioning it into something that can live in a factory? That's why we're here. There's been a lot of work on the additive manufacturing. We're still talking about who officially kind of becomes the champion, but that's coming together. And then ROS Workbench is something that's been presented a handful of times. We talked about it at the annual meeting as well. It's just to provide more manufacturing engineering centric ability to interact with ROS-based systems at a very high level. And so that's coming along. If you're interested in any of those, please reach out. I included a little bit, like based on our ease of use feedback from the manufacturing engineering community, what is now kind of being called SWORD, and it can contain some things about more efficient CAD ecosystem to URDF, being able to create various types, you know, how do we interact with these industrial robots? How do we create collision models, et cetera? So stay tuned. Some people are already involved in the beta. If your organization is interested in this beta, reach out to me. I can make the intro and we can get you involved. Obviously, I included the link here. Yaskawa helped us out, get us access to some welding related hardware. We merged it with the prior work from Institute Meritus on the ROS additive framework. Did some driver changes, looking at like basically some different approaches or leveraging the past RMI style driver, and incorporating a lot of the more advanced toolpath planning and motion planning tools we have to create a full, basically open pipeline to facilitate additive manufacturing. So we ran a pilot. There's a blog post out there in this video. If you're interested in getting involved or hearing more about that, again, just reach out. That's it for my little high level what's going on in ROS I land. I'm going to kick it over to Michael. Michael, you're online? Do you have audio?
Yeah. So in terms of like technical updates for some of our ROS I tools, we've been working quite a bit recently with our REACH study repository. So I wanted to highlight that for a couple minutes, give a little overview of what it does and some of the improvements that we have been making to it, and then got a handful of other things before I will let somebody else take the reins. So anyway, yeah, this REACH study repository is something that we put together a couple of years ago to help us design sort of custom robots. So the idea here is, maybe we have a couple of different designs for a particular robot system, and we don't know which one, is going to be better or the best for a particular application. So we want some sort of quantitative way of seeing how much of the kind of predicted workspace each robot concept can reach, and then attempting to assign a score for how well those robot concepts reach the points in their workspace. And so that's sort of the idea of this repository here, is that we can put together a URDF model of our robot, and then we've got various different objects that we might want to be working on. So in this particular case here, we have this mobile robot that's trying to operate on the surface of an aircraft. So we basically generated a whole bunch of points on the aircraft and tried to solve IK for all those points and provide some score about how well this robot did. So yeah, so nominally that's sort of the idea of this REACH study. And so we've been using it recently and making some improvements. So I wanted to share a couple of those. So one, we've added a little bit more in terms of documentation. We did a presentation at ROSCON a few years ago. So I added a link to that and added a little bit more to the README to hopefully make it a little bit easier to use. We've also been getting some contributions from, I believe, Picnic in terms of getting ROS II support and adding some additional capabilities from the Move It side to some of the plugins that exist here. So that sort of spurred a little bit of discussion about like how do we take this repository and convert it from what it currently is in ROS I to something that's compatible with ROS II. So I think we've got some ideas there and have started a little bit of work on sort of porting the core stuff to ROS II and making it sort of compatible with ROS II as well. So that's in the works, still in progress, but look forward to that. Probably in a couple months, I think we'll be at a point where we can run this natively in ROS II. So in addition to that, we've added some more capabilities in terms of evaluation scores. So nominally, like the biggest thing that we've used for evaluation scores for this is using the manipulability of the robot at a particular pose to provide a score for how well it reached that pose. So one of the challenges with that is that manipulability value scales with the size of the robot. So the bigger the robot you have, the higher the manipulability value. So it makes it kind of hard to compare two different robots that aren't exactly the same size. So what we've done is we've added two new evaluators, one that uses the length of the kinematic chain as sort of a scale factor for the manipulability. That way it makes two robots that aren't exactly the same size scale, so you can sort of compare them apples to apples. We also added another evaluator based on manipulability as well that looks at the ratio of the largest value of manipulability to the minimum value and returns that ratio on a scale of 0 to 1. So that's also been pretty useful for the use case that we've been working with here recently as sort of trying to maximize general manipulability as opposed to being really good in one direction and not so good in another direction. So definitely check those out. I think they have documentation. Both those things exist in this Move It Reach plugins package here. So I got a quick kind of show and tell of some of the other stuff that we've been doing with this as well. So we actually have a demo of that's runnable to sort of show you how this reach study works for this particular application. We just have a hood of a car and a robot here. So you can download this and build it and run it. So some of the stuff that we've recently added here is some improvement to the visualization. So previously we were just showing sort of binary colors about whether a point was reachable or not. But we have recently changed that to sort of show a heat map of reachability in sort of color form here. So points that scored the highest are colored red, sort of like they're hot. And then points that had the lowest scores of manipulability are colored blue. So you can kind of get a sense of, for an object where you're reaching, what poses produce the best scores and which didn't. And then these black ones were points that were not reachable. So for those of you who haven't used this as well, it's got some other cool features here of the visualization. So once you run the reach study on these particular points, you can click on them and show what the resulting pose was to get a sense of what the robot looks like when it goes to these points, and some other cool things. So along those same lines as well, this visualization is useful, but it's sort of hard to tell, on the whole scope of the part, what the reachability really looks like. So we've done some work in the past to visualize this as a heat map, and that's always been something that's kind of existed locally on my computer. So we did a little bit of work to improve how that heat map calculation works, and we're hoping to contribute this back to the repository as well. So this is an example from that reach study. If we sort of interpolated the scores across the entire surface, this gives you a much richer detail of what the reach capability of the robot looks like on this particular part. And so you can take a mesh that has lots and lots of vertices and triangles here and get a pretty high resolution, relatively accurate view of the reachability, even though you only sampled at some small fraction of all these points. So this is a really cool feature for sort of understanding the reachability of a robot a lot better. And so we're hoping to contribute this back into the repository sometime soon. So along those same lines, we actually did this interpolation and heat map creation in Python, and some of the work that we've been doing right now is focused a lot on sort of taking the results of the reach study and using tools in Python like SciPy and NumPy and Pandas to do sort of analysis of the reach study, and that's been really convenient and really sort of insightful in terms of tools. And so I think that's something that we're thinking about now, as well as trying to take the core code that we have and write a Python interface for it so you can run it in Python and sort of combine it with some of these other nice data analysis tools that already exist in Python. And sort of one last step beyond that as well is we started to look at running this reach study sort of in terms of a meta optimization. So if we had a robot that we were designing and the links and geometry was configurable, it would be nice to use this reach study to help us determine what the optimal links and configuration of the robot should be, and run a reach study on an object to kind of give us a score about how well that particular configuration worked, and then optimize that geometry. So we're working on some software right now to kind of iteratively run reach studies to optimize links and geometry. And so I think that's something that we're hoping to be able to contribute back, as well as sort of taking this and using this as a building block and a larger optimization for geometry of custom robots, which is pretty exciting. Yeah, so I think that's pretty much everything I wanted to share as far as the reach study improvements go. It's a cool tool. We found it to be fairly useful in a lot of the work that we do, so definitely check it out. That exists here at the ROS-Industrial GitHub organization, repository called Reach. And I think a couple other things I wanted to share as well, like Matt touched on, we have made a few minor improvements to the Scan and Plan workshop repository. And our interns over the summer have added another implementation of a Scan and Plan application to that we're working on merging in. So there'll be another example of how you port this whole Scan and Plan application to a different set of hardware for a slightly different use case. So definitely keep an eye on that repository. We're hoping to get that merged in and finalized probably by the end of the year. Let's see. And I think along the same lines, we've also, Tyler Marr has been making a few updates to the industrial reconstruction repository as well. So sort of continuing to improve on that. And I saw some comments this morning about taking that and getting it to run in ROS I. So it sounds like, I think Heish has put together a ROS I version of industrial reconstruction, as well as the current ROS II version. So it should be usable in both distros.